And so this node, why it is possible to fly, has many reasons. There are related nodes, why it is possible to sail, why a frisbee flies so well, why a propeller can give thrust, how a wind turbine works, why paragliding is possible, why birds can fly, why a helicopter can fly, why a bumblebee can fly, how a boomerang flies, why a topspin tennis ball curves down, and so on. So there are quite many, and maybe we could take the last one here, since we are in Norway. And we remember that André made his Arctic expedition about 100 years ago in competition with the Norwegian explorers. So André, he had a theory that it would be possible to control the flight, steer an air balloon by drag ropes. Ropes extending from the balloon and then dragging on the surface to give some resistance. The question is, and he claimed that he could steer then the balloon off like 20-30 degrees off the main direction of the wind. So these drag ropes were mounted on the air balloon and they set off, but of course it didn't work, and the drag ropes got stuck on the ground and so on. He lost the control mechanism that was maybe not there at all. So the question is, was the theory of André correct or not? Is it possible to steer a balloon by having ropes dragging on the ground, giving some friction? And maybe you mount a little sail on the balloon. Shall we take this one or some other?
Take this one.
Okay. And then I can tell you that also that this is a so here is an example of fluid mechanics. So here is the balloon. You see the drag ropes and you see the sail. Okay. So does this work? Well, André, he was convinced that this would work, and he even claimed that he had made several experiments, tests, showing that it was in fact functional. So here he is explaining his theory to two of his Strindberg and Frenkel that followed him, and one dropped off because he didn't believe in the theory, and they all died, as we know. Here is the cheering crowd as they set off, because that was sort of nationalistic feelings in Sweden at that time. So is the theory correct or not? Well, the way I present it is that you can, if you read the notes about why it is possible to fly, why it is possible to sail, then you can understand if it is possible or not. And it is an open question left here to the sort of interested reader to discover. But I can tell you then that my analysis of this, so what do you think? Is it possible to steer the balloon 20 degrees off the wind direction by having ropes dragging on ground, mounting a sail that we saw?
What is the drag ropes do exactly?
Yes, but then, okay, so there are two things to understand. So first you have to understand how it is possible for a sail to give drag forward on a sailing boat. This is the same principle as the mechanism for generating lift of an airfoil. So the sail acting like like an airfoil gives a forward force, it's a lift force pushing forward, but it also gives a sideway force, and the sideway force is balanced by the keel of a sailing boat, And the keel also acts like an airfoil, giving a lift, which is then perpendicular to the direction of the boat, basically balancing the side force on the sail. So you have two airfoils on a sailing boat, giving some side force, because to get the push forward, the thrust of the sail, you also get the sideways force that you balance by the keel. So evidently without the drag ropes it's impossible. You will just go with the wind with the balloon. It will not be, you cannot control the direction. Well, it is a little bit open, in fact, if it is possible to do this. But my feeling is that the drag ropes, first you will say that it's impossible, that you cannot do this, because the drag ropes, they don't act like a keel. They are they're dragging on ground, gives a friction force which is then directed in the direction of motion. But I haven't really decided if it maybe André after all was correct, and I leave it up to you, as I have left it here, to enter into the knolls on why it is possible to fly and why it's possible to sail. And if you understand that, you should be able to figure out if André's idea is functional or not. So on this limited time here, I try to give some examples of basically presentation of FEniCS related work. And what I have found productive is to see that there is a wealth of applications that come out from FEniCS. Once you have the basic computational engine in place that can solve PDEs, there are endless number of interesting problems that you can address. And in particular in aerodynamics, it seems to be an area where computation only now can give some real insight into the reality of aerodynamics. And basically the old math formulas in aerodynamics are mostly wrong. They are invented, magical or completely incorrect solutions without relevance. So this is an example which we have found in our work with Johan and Johan, that in fact computation makes it possible to discover new phenomena, and everything comes from the new possibility of computing solutions of particular PDEs. And you can extend this idea if you go into the area of quantum mechanics, which is also, like aerodynamics, an area with lots of formulas, but many of them seem, and it is basically a nightmare to enter this area, like aerodynamics, because you cannot understand it, and it's filled with various principles that you cannot understand. And also, in particular, as we saw in this Gary Larson cartoon, quantum physicists pride themselves by not understanding quantum mechanics. Quantum mechanics is presented as something magic which you cannot understand. And this is an attitude to science which has come through mathematics. Because mathematics, by some, is something considered to be magical, which you cannot understand. And if you go back to the cartoon with Einstein as being stupid,